All right, this starts Unit 1. Unit 1 is about the trig identities. First of all, there's a sheet online for all the trig identities, or I'll hand it out if you're in class. We're going to do them in sections. This first section, it talks about the reciprocal identities, the quotient identities, the Pythagorean identities, and the negative angle identities. Now, the reciprocal identities we've actually already used. That's these right here. We know secant is the reciprocal of cosine. We know cosecant is the reciprocal of sine. We know cotangent is the reciprocal of tangent. So those are the reciprocal identities right there. The quotient identities are new. There's only two of them. One says tangent equals sine over cosine. And then cotangent then is the reciprocal. It's cosine over sine. So those are the quotient identities. The Pythagorean identities, there's three of them. They actually come from the Pythagorean theorem. Sine squared plus cosine squared equals 1. We use this one a lot. Sine squared plus cosine squared equals 1. We also have tangent squared plus 1 equals secant squared. And 1 plus cotangent squared equals cosecant squared. Those are Pythagorean identities. The last set on this first one are called the negative angle identities, and they're out here. 2/3 of them work like you would think. Like the sine of a negative theta is the same as negative sine theta. The cosecant of a negative theta is the same as negative cosecant of theta. Down here on the bottom, the tangent of a negative theta is the same as negative tangent theta. The cotangent of a negative theta equals negative cotangent theta. So to me, those are just like you would think. If you add a negative on the left, you put a negative out front on the right. The two that don't work that are cosine and secant. And this is because of the quadrants again. The cosine of a negative theta is actually the same as the cosine of a positive theta. Again, that's because of the quadrants. Like let's say we had the cosine of 30 degrees. Well, that's in the first quadrant. Cosine is positive there. Well, what if we had the cosine of a negative 30 degrees? Well, that's in the fourth quadrant. Remember, cosine is also positive there. So that's why it works that way. Same way if you had the cosine of 120 degrees. Well, that's in the second quadrant. Cosine is negative there. If we did the cosine of a negative 120, that's down in the third quadrant. Cosine is also negative there. So the cosine of a negative theta is actually the same as the cosine of a positive theta. Same way the secant of a negative theta is the same as the secant of a positive theta. But that's the set of identities we're working right now. Now these identities we can use in lots of different ways. A lot of times it's to simplify. Like if I had this one. If I had secant squared x minus 1, and I say, I want to simplify that. This might be a matching problem. Well, if you look through your list of identities and look at any of them that have secant squared theta in it, we'll notice this one here. It says tangent squared plus 1 equals secant squared. Well, if we put in that in for secant squared, if I put tangent squared plus 1, right, you see that? If I have tangent squared plus 1, that's the same as secant. That means we can substitute it in. So in here for this secant squared, I'm going to put tangent squared plus 1 in place of that. So right there, I'm going to turn that into tangent squared x plus 1. Now there's still a minus 1 out here. Well, if we simplify that, the 1's cancel. That's the same as tangent squared x. So if this was a matching problem, if in one column you had secant squared x minus 1, and in the other column you had tangent squared, you know those two match. So that's one kind of problem, matching problems. You can also use them to find trig functions. Like here, find the sine of theta if cosine theta equals a negative 3/4, and theta is in quadrant 3. So we want to look for an identity that has these two in it, that has sine and cosine. Well, and just those two. Well, you notice this fundamental identity says sine squared plus cosine squared equals 1. So you can see it only has sine and cosine in it. So let's use that. So if we start with that identity, sine squared theta plus cosine squared theta equals 1. Now let's substitute in. The cosine is a negative 3/4. So here in place of cosine squared, we're going to put a negative 3/4. And cosine squared means we're going to square that. So now this problem looks like that. Well, let's see, if we square that, a negative 3/4 squared. If you square a fraction, you square the top, so that's 9. Square the bottom, that's 16. So now this problem looks like this. We want to find sine theta, so let's subtract the 9/16 to the other side. So if we subtract 9/16, so on the left we have sine squared theta. Here, 16/16 minus 9/16 is 7/16. Now, we want just sine, so to get rid of the squared, we need to square root both sides. So sine theta equals, don't forget, plus or minus when you square both sides. Now remember, to square root a fraction, you square root the top. So on the top, we have the square root of 7, and square root the bottom. On the bottom, the square root of 16 is just 4. So we have that. Well, now, should that be positive or negative? Well, this is where the quadrant thing comes in. In quadrant 3, sine is negative. So here we want the negative one, so it's a negative radical 7 over 4. That's what the quadrant was for. So it might be a problem like that. Sometimes you'll just be asked to simplify. If I have cosine theta times cosecant theta, and it says convert that to sine and cosine and simplify. Well, cosine is already cosine, so let's just leave that the same. But we know by the reciprocal identity that cosecant is equal to 1 over sine. So let's substitute that in. We have cosine theta times, instead of cosecant, we're going to put 1 over sine theta. Well, if we multiply that out, that's going to be cosine times 1 on the top and 1 times sine on the bottom. So we have that. Well, it says and simplify. Well, if we look at our identity sheet, cosine over sine, if you look at our quotient identities, you can see here that cosine over sine equals cotangent. So that simplifies as cotangent theta. So we simplify it. There's a lot of uses for simplifying these. Look at this next example. We want to simplify cosine squared minus sine squared over sine theta cosine theta. Now on this one, a lot of times if you see here on the bottom, we have one fraction. On the bottom, we have a single thing on the bottom. This is all multiplied together, and the top is 2 separate. A lot of times when you see that, we want to split this into separate fractions. If that top is not matched right to an identity, which this one doesn't, we might split it. So if we do that, now we have cosine squared theta over the denominator minus sine squared theta over the denominator. If you think about that, if I gave you this problem, if we have a common denominator, can't we go ahead and subtract and make it look like that? We just did that in reverse. Well, now if you look at this, here I have a cosine squared on top and a cosine on the bottom. Let's divide top and bottom by one of those cosines. I'm left with a single cosine on top and a sine on the bottom. Same way on this, and I have a sine on the bottom and a sine squared. Well, let's divide by one of those sines. So let's get rid of divide this one and one of these. That leaves me this sine theta over cosine theta. Now, if we see if we can simplify that, again, we look for something like that on our sheet, like cosine over sine. Well, on our identity sheet, if you look at the quotients, cosine over sine is cotangent. So this first one is cotangent theta. Here, the second one, it says sine over cosine. If we look on our sheet, sine over cosine is tangent. So let's replace that with tangent theta. And we're done. We simplified it. You want to keep that identity sheet handy because we're going to use that over and over. You'll look at it all the time. This next example, simplify this to a single term or a product of terms. Well, we have cosecant minus sine. Now it says a single term, so we would like to combine those. Well, we know that cosecant, by our reciprocal identity, is 1 over sine. So let's change cosecant to 1 over sine minus sine. Now, in order to subtract these, we need to get a common denominator. Well, this one just has a denominator of 1. We want it to have a denominator of sine. So just like if this was, say, 1/3, we would multiply this one top and bottom by 3 to get a common denominator. Here we want to multiply top and bottom by sine theta. Well, if we do that, now on the top we'll have 1 minus sine times sine, so that's 1 minus sine squared theta. On the bottom, now our common denominator is sine theta. Now, if you look at this top, if we look at our identity sheet, see this first one where it says sine squared plus cosine squared equals 1? If we took sine squared plus cosine squared equals 1, what if we moved the sine squared to the other side? What if it said cosine squared equals 1 minus sine squared? So now you can see here that 1 minus sine squared is the same as cosine squared. So on the top here, could we take that 1 minus sine squared and turn that into cosine squared? So now it looks like that. That still doesn't really match an identity, but we could rewrite that. If we took a cosine theta out, that would leave us with a cosine theta on top and a sine theta on the bottom. Well, that helps us because that's an identity. Remember from our quotient identities, cosine over sine is cotangent. So we can change that to cotangent. So we still have a cosine theta. Now we change this to cotangent theta. Notice our instructions said change to a single term or product of terms. Well, now we have a product of two terms. These will seem really strange to you. We'll do them enough, we'll hopefully get used to them. All right, the last four here are using the negative angle identities. So like this first one, if I know the sine of 30 is 1/2, what's the sine of a negative 30? Well, from our negative angles, it says the sine of negative theta equals negative sine theta. So the sine of a negative 30 equals negative sine 30. Well, the sine of 30 is 1/2, so that's negative 1/2. Or this one, if I know the cosine of a negative pi over 4 is radical 2 over 2. Well, remember cosine, they're the same. So the cosine of a negative theta is the same as the cosine of a positive theta. So here the cosine of a negative pi over 4 is the same as the cosine of a positive pi over 4. Right? So that identity says the cosine of a negative pi over 4 is actually the same as the cosine of a positive pi over 4. So that is also radical 2 over 2. The next one says the tangent of a negative 2/3 pi is radical 3. What's the tangent of a positive 2/3 pi? Well, notice from identity, the tangent of a negative theta equals negative tangent theta. So the tangent of a negative 2 pi over 3 equals a negative tangent of 2 pi over 3. So the sign changes. So here if the tangent of a negative 2/3 is a positive radical 3, the tangent of a positive 2/3 equals a negative radical 3. Here's the secant one. The secant of 2 pi over 3 is a negative 2. What's the secant of a negative 2 over 3? Remember, secant's like cosine. If the sign of the angle changes, the sign of the trig function does not change. So if the secant of 2/3 pi is a negative 2, the secant of a negative 2/3 pi is also negative 2. So they're both the same. So that's 5.1 trig identities, the first part of trig identity.